This recording is to show you how to apply the superposition theorem to a simple circuit containing two sources. So over here we have a 64 volt constant voltage generator and another one on this side at 64 volts, a 4 ohm resistor at the top, and then a 6 ohm resistor and a 4 ohm resistor. The superposition theorem requires that we suppress the generator so only one generator is active at any one time. So taking the left-hand side of the circuit first, we're going to suppress the generator just here, which means replace it with this internal resistance, which is 0. So the next diagram below shows the constant voltage generator here has been removed and replaced with a link. I now have a simple circuit with a 64 volt source and 3 resistors. I need to work out the current flow and all of those components. So looking at the circuit on the right hand side, I would see I've got two parallel components there. Product over sum for that is going to give me 24 over 10 or 2.4. Get it right. Ohms. So 2.4 ohms there plus the 4 ohm resistor gives me a total resistance for the whole circuit of 6.4 ohms. So the current that flows out the 64 volt generator on this side, just here, I is going to be 64 volts divided by 6.4 ohms, which easily is 10 amps. I have 10 amps that's flowing towards this junction just here. At the junction, 10 amps splits between the 6 ohm and 4 ohm, so we're going to need to share the current just there. So to share the current, I would say, let's look at the current down here, and we'll call that I1. I1 is going to be the incoming current, 10 amps, multiplied by a fraction. The bottom of the fraction is the 4 ohm and the 6 ohm, just here and just here. The top of the fraction, if I want to find the current in the 4 ohm resistor, I have to put the opposite value, the 6 ohm, on top. So it's 10 amps times 6 over 10, 0.6, which is 6 amps. So therefore I have 6 amps in the middle resistor and the current in the second resistor, which I'll call I2, is simply going to be 10 amps minus 6 amps, or 4 amps. So my currents are 6 amps just here, 4 amps just there, and 10 amps just there. I now look at the next circuit. So on the next one, I have suppressed the left hand side generator, and I'm left with now the right hand side generator, and I go through the same calculation again. I need to know the total resistance in the circuit to get the current coming out the source. So I'd observe I have two parallel resistors there. A 4 and 4 in parallel make 2 ohms. So effectively I've got a 6 ohm resistor and a 2 ohm resistor in series, which gives me 8 ohms of course. So the current just here coming out of the generator, I is going to be 64 volts divided by 8 ohms, which is 8 amps. 8 amps is coming down here, get to the junction just here, sees two equal paths, a 4 ohm there and a 4 ohm there, splits equally down each. So I'm going to have 4 amps down here and 4 amps just here. So I now have the individual circuit values. I now need to put them together. So thinking about the one we just did, we've got an 8 amp here pointing right to left. We have a 4 amp here going down and another 4 amp going that way. Looking at the first circuit, we've got 10 amps and then 6 and 4. So 10 amps there, 6 amps there, 4 amps there. I now say to myself, what's the overall picture going to be then? So looking at the left hand side 4 ohm resistor, 10 amps going left to right, 4 amps going right to left. Overall I've got 6 amps. Apologies. I've got 6 amps on the left there, and on the right hand side I've got 8 amps going right to left and 4 amps going left to right. So overall I've got 4 amps just here, right to left. In the middle I've got a 6 amp and 4 amp in the same direction, so I've got 10 amps. So now I have the overall picture for the circuit. This can be extended to circuits containing many sources, and each of the sources will be suppressed, leaving only one source in the circuit at each time to work out the current flow. Thank you.